Here. That's really not enough to... There's different ways to approach these problems. I'm going to tell you the way I do it. And this is kind of a general approach. I can teach you a method to attack this particular problem, and like a cookbook, like you do this, then you do this, and you do this. That, to me, that's not very meaningful because you may not ever see this exact problem again. So really, I'd rather try to teach you like an approach. And the approach that I would take, first you're going to write the equations that you can right up here, and then I'm going to kind of look at it naively, and I'm going to look at what other equations can I write up here. And at some point, if I can put one equation into another equation and get it down to one variable and solve for that one variable, then I'll have the problem licked. If I can solve for bx, then I know ax. And once I know ax and bx, then I know ay, and then I can solve. If I know any one of these, ax, bx, or by and ay, if I know any four of those, just one of them, I can get all the rest of them. If I know ax, I can solve for ay, and I can get bx and by. So I've got to write an equation that I can substitute in here so I can relate it. So if we can have some kind of relationship, I'm just going to start stupidly here. I'm just going to say, so that's 40, so this is 50, and this is 60. Right? So we could say, write an equation here, sine of 60. I literally don't know how to do this problem. I'm just going to work through it here. So and I may run some dead ends. Sine of 60 is equal to ax over a. That sine of 60 is equal to the opposite over the hypotenuse. Okay, I've written it down. So this one has to be 30. I can write sine of 30 is equal to ay over a. I can write, tangent of 30, what's that going to be? Opposite over adjacent is equal to ay over ax. Anybody see anything yet? Is there any way we can substitute any of these and solve for the ax or the bx, or the ay or the by? Nothing just pops out to me. We could set these things to be equal because they both got the a in them. So we can solve both. I'm going to take this one and solve for a. So we'll say a is equal to ax divided by sine 60. And we've also got a is equal to ay divided by sine of 30. Let's take these two equations and just reorienting them. So these two, I can write another equation, so that's equal to ay over sine of 30. I just put this part center there. Doesn't look like I'm going anywhere. I think I actually made some progress on that last one, maybe. This may not be the right approach, but see, I've got ax equal to ay. So I can write this term here. I can write this in terms of ay if I like. I can do the same for bx if I wanted. I could take this by here. I didn't do anything in terms of by. I can do the same approach on the other side. I start playing with these equations and try to find one where I can substitute in here and get ay by itself. Ay is equal to all this other stuff, and the only unknown is ay. Or likewise, I can try to solve for by and get that isolated by itself.